Hi students, today we will learn about transformer ratios. In our previous class we learned about transformer. First we will learn about voltage ratio. What do you mean by voltage ratio? The transformation ratio or the voltage ratio is defined as the ratio of the secondary voltage to the primary voltage. It is the ratio of the secondary voltage to the primary voltage. Secondary voltage can be represented using the letter Vs and primary voltage can be represented using the letter Vp. Therefore, transformation ratio or this transformer voltage ratio can be represented as Vs by Vp. This S stands for secondary and P stands for primary. You can also use the letter E instead of V. Es by Ep. Therefore, the transformer voltage ratio is Vs by Vp or Es by Ep. Next, we will learn turns ratio. Turns ratio is represented using the letter N. It is defined as the ratio of the number of turns in the secondary coil to the number of turns in the primary coil. Turns ratio is equal to secondary turns divided by primary turns. This transformer ratio, turns ratio is Ns by Np, where Ns represents the secondary turns, Np represents the primary turns. For most transformers, the turns ratio is fixed and cannot change. What is the relation between voltage ratio and turns ratio? For transformers with small transformation ratios, the turns ratio is equal to the voltage ratio. That is Vs by Vp is equal to Ns by Np. This is the turns ratio and this is the voltage ratio. The primary and secondary terminal voltages of a transformer are proportional to the respective number of turns in the transformer, or Es by Ep is equal to Ns by Np. Instead of V, you can use the letter E also, Es by Ep. Es represents the magnitude of EMF or voltage induced in the secondary coil, and Ep is the magnitude of the EMF applied in the primary coil. We know in a transformer we will apply the voltage in the primary coil, and due to mutual induction a secondary voltage is induced in the secondary coil. Can you state two factors on which the magnitude of an induced EMF in the secondary coil of a transformer depends? We learned Es divided by Ep is equal to N. Therefore, what is Es? Es is equal to Ep into N. Can you state two factors on which the magnitude of the induced EMF in the secondary coil of this transformer depends? It depends on Ep and N. Es is equal to Ep into turns ratio. That means it depends on turns ratio N and the input voltage Ep. What is current ratio? Current ratio is defined as the ratio of the secondary current to the primary current. If you use the letter I to represent current, Is divided by Ip will be the current ratio. Current ratio is equal to secondary current divided by primary current. If you are considering an ideal transformer, the output power and the input power are equal. Output power is the power in the secondary coil. That should be the same as power in the primary coil, because ideal transformer is an imaginary transformer which does not have any loss in it. It means no core loss, copper loss or any other losses in the transformer. In fact, no transformer is ideal. What is the expression for power? Power is equal to VI. Here you can use the letter EI. For secondary, you must put ESIS. For primary, you can write EPIP. Therefore, power in the secondary coil is equal to power in the primary coil. ES/IS is equal to EP/IP. From that expression, you can write ES by EP is equal to IP by IS. But ES by EP, we learn this as NS by NP. The turns ratio is equal to the voltage ratio. But here ES by EP is equal to IP by IS. ES by EP, here it is NS by NP. Comparing all the three, combining all the three ratios, voltage ratio, current ratio and the turns ratio, you can write IP by IS is equal to ES by EP is equal to NS by NP. Please note that this is S here, NS turns ratio, voltage is also secondary, but the current here it is primary. Here it is P and P, here it is S. When you are considering the current, it is IP by IS. P is equal to VI. If voltage is doubled in this secondary, current is halved in the secondary. Similarly, if voltage is halved in the secondary, current is doubled in the secondary. All the power delivered to the primary by the source is delivered to the load by the secondary. Please remember the relation between the three ratios. The relationship is IP by IS is equal to ES by EP is equal to NS by NP. It is easy to remember this. Remember, voltage ratio is the same as turns ratio. Therefore, ES, NS, EP, NP. But when it comes to current, you must take IP by IS. Thanks for watching the video. If you like it, please share with your friends. If you have any questions, please contact via email pjscracker@gmail.com.